I'm honored to invite the first pitch or the first companies, Addionics. Welcome them. You have
Good evening, everyone. Can you hear me? No? Okay, I'll use the mic. Okay, now it's okay or not? Maybe it's the mic. Okay, no. Cool. So my name is Moshiel. I'm the founder and the CEO of Addionics. We're early stage startup in the space sector, but we are not an early stage startup. We just raised our B round. We raised more than 90 million US dollars. Where is the clicker? Okay, cool. And I will tell you, before starting, I will tell you the story of Addionics and why and how we entered to the space market. So we are developing smart metals, and our flagship product is for batteries. We're changing the architecture of the batteries by our smart metals. We are designing, manufacturing, and integrating the smart metals into battery manufacturing lines. And we raise money from strategic investor, financial investor like General Motors, Scania, Avery Dennison, big names that many of you are familiar with. And 3 years ago, we started a company more than 8 years ago. And 3 years ago, our VP product, actually 2.5 years ago, came to me and told me, Moshiel, you are wrong. I was speechless. Like, what do you mean I'm wrong? He said, you are developing your product through design partnership, always working with the end customer, and the end customer is telling you what should be the product, how you develop the product. And I'll tell you a secret. Our customers don't know what they don't know. There are lots of gaps that they are not familiar with. Okay, so what is your suggestion? He said, I want $2 million. I said, what? No way. You are not going to get $2 million. I said, yes, I want to build our own batteries. And I found a lab in North America where I can build specification for certain advantages that I really believe that we can improve. I said, okay, you don't have $2 million, you have only 200K, start working. And why I'm telling you that story? Because at the same time that we started to work with this, I would say, credible lab, that the first lab that started to work with Tesla to develop the batteries, a big space company, they have communication LEO satellite, they started to see how ironic is the energy. This is the silent battle many of you know, but the majority of the people, these satellites do on average 10 spins a day. You have 90 minutes each spin, 60 minutes light, 30 minutes dark. This satellite is doing lots of cycle. Of course, there are solar panels that can store energy, but there is no any application on space that can demonstrate similar conditions. And all the batteries on Earth are designed for mass production, for commodities. And this very prestigious space company, some of you mentioned that company many times here, actually looked for their solution. They went to the biggest battery companies in the world and asked, we want customized solution. We need many cycle life. We need high energy density per weight. We cannot have heavy batteries like storage application. And they asked them, how much capacity you have? They said, 50 megawatt hour. It's like 300 vehicles. It's nothing. We are not going to the production lines and produce batteries for you, customized for you. So what that company did, they went to the lab that we work with, and we got the connection. And that's the story how we started to work in the space application. And now we are not only in labs developing those type of batteries, we are going towards the stars. And hopefully everyone see that. This is one of the reasons that you need customized solution. The majority of the batteries built for the mass production commodities, and we know that with all the boost of energy these days and communication and defense, you need customized solution. And the conditions, as I mentioned before, are not suitable for what's available in the market. And the solution for that is really to make different in the architecture and design. And in batteries, traditionally, most of the focus was on the chemistry of the battery, on the anode side, on the cathode side. but no one actually developed physics. And now that's how we started the company. I have semiconductor background. 15 years ago, I moved to the battery space. I gained a PhD in battery science, and then started to say, how can we bring the semiconductor brain into the battery? And the shift in the architecture that we can design in a way, with a physical way, better structures that will handle the conditions, the requirements, the specifications that needed to be in space are critical for specification. In space, each mission is different. Each satellite requires different performance. So we are replacing traditional component that in every battery called current collector. It's a 2D metal foil. On the anode you have copper foil, on the cathode you have aluminum foil, similar to the kitchen foil. And believe it or not, it doesn't change in the last 40 years. Every battery company uses those traditional foil that you have in your house. And we are making them porous and 3D. And why we are doing that? To improve performance and to customize, to make sure that we are building the necessary application for space application. So what it's going to do, better adhesion, high energy density. With this space company, we managed to demonstrate 12% increase in energy density in their cell and 30% improvement in cycle life. And you don't have garage in space, so you cannot replace and switch batteries in space. And the lifetime, and that's very ironic, the lifetime of the battery determines the lifetime of the satellite. And the battery, it's below 1% of the cost of the satellite. So if you're going to invest in the battery, you're going to extend your lifetime of the satellite. So I'll just finish with our status with collaboration with leading companies. And this year we're going to have few satellites, communication satellites with our technology inside the satellites. And next year we already have a commitment of 50 megawatt hour of batteries in space with our technology. And this is our mission, to bring better energy to space application, and of course to make impact for everyone. Thank you very much.
Okay. Audience, you can scan the QR code and start evaluate the company. Judges, do you have any questions? I have a mic. Who wants to go first? Pete.
Of course, the key thing here is testing in space. So when does that happen?
So this year we're going to have the first few tests in space. We did some lab tests last year. And after those tests, I think although all these test procedure and things change with the new type of companies that willing to take risk and even to send few satellites without all the extensive testing that been done before. So we are also, these companies doing some shortcuts. We know that it's a risk, but this is a risk that those companies are willing to take in order to make these improvements.
The fact that it goes to space makes it more complicated in terms of the technology and more expensive, or in theory it's the same solution to Earth?
It's same solution. We are designing and customize the solution per the application itself, but this ability is for any application on Earth, either on Earth or space, so there is no any limitation for that.
So what is the portion of space application in your portfolio, in your business model?
It's still very small. It's a smaller market compared to automotive market, for instance. We're talking about trillions of dollars of market compared to billions of dollars of market. So it's still small, but it's a validation and also a mission that we want to be part of.
You mentioned the fact that you're going from 2D technology to 3D. Is there any analysis or anything you can project on the performance difference between those two different technologies? How much more of a benefit do you get with your battery technology?
Sure. So I just mentioned a few seconds ago that we demonstrated in the lab, not in space yet, with that customer that we can improve the energy density per weight by 12% and the lifetime by 30%. The lifetime of the battery, which determines the lifetime of the satellites, this LEO communication satellite.
Hello, down the road, the cost compared to the traditional battery.
So yeah, I think we are lucky that we started with the automotive market, which are very sensitive to cost. So at the end of the day, our application is suitable for the automotive market, so it's also definitely suitable for smaller, I would say, volume and I would say space application. So it's at scale, it's not going to increase the cost, it's even going to reduce the cost by 10%. We are just optimizing the structure of the battery, so it's more effective battery per kilowatt hour. But at the end of the day, when you are doing small volume for space application, of course, also in the market, you'll find that it will be more costly than commodity batteries.
Okay. Thank you so much, Moshiel.